Hello, good morning, and welcome once again. I hope you had a wonderful night's rest. Thank you for having me again in today's class. And sorry for yesterday. I couldn't make it. Many things were on me. Like many of you are aware that I'm currently doing my lab work for my MSc. So please bear with me for not being able to drop a video yesterday as promised, and also assignment. If you are watching this video and you are not part of my WhatsApp group, those that I'm training on JAMB, you may drop a comment on the chat box if you wish to join. So meanwhile, I'm after only serious students. Please, if you cannot be committed to giving a minimum of an hour per day to carry out some of the tasks I will be sending on the group, there is no need to join us, please. Thank you so much. I'm not after a crowd. I'm after a few that can be committed. I'm okay with that. I don't want crowd that will just be there and are not doing anything. All right, welcome back again, my student. If you are my student, you already know how we used to do it. All right, so thank you so much. All of you have been doing well. For those of you that have been submitting my assignments so far, you have been doing well. So I'm so proud of you, especially the last assignment. I was so happy with your performance. So there is an improvement. You are getting it. And I hope you will not quit. I hope you will not skip a day. I hope you plan very well to follow up. I tell you, before this month finish and we enter March, before middle March, by God's grace, we would have covered much. And you'll be surprised what you will see in JAMB. I assure you, because I know how I'm strategically bringing questions for you. And not only questions, you can testify that I teach you some hacks. I show you some principles. I show you some ways that have helped me to excel in my academics, even at my university level, up to this level of my MSc. So I will continue to give you any support you need, both privately and at the group level. So I'm committed to seeing that you excel in JAMB this year. Yes, it's possible to have a very good score in JAMB. I assure you. I have shared my testimonies now. So on how I got 332 or so. So I assure you that you can also get that. You can also score high. So please stay tuned. If you have not if you have not subscribed, for my students, if you are my students and you have not subscribed, subscribe so that I don't need to be sharing the link every day. Once I just send, it will pop up. Just click on subscribe and then the reminder button, that bell, just click on it. So anytime I post a video, you will see it. So you don't have to, if you are new or you are just watching for the first time, I don't know, if you would like to join, like I said, please, I'm after serious students. If you can be committed, you can subscribe also and drop a message for me on the comment section. I'll find a way of reaching out to you to give you the WhatsApp link so that you can join us. All right, thank you once again. This morning we will be treating some past questions that I have carefully selected over the past years. Yes, when I say carefully selected, understand the language I'm using now. So I'm not giving my students anything anyhow. I'm giving you questions that are likely to show up in JAMB 2025. So stay tuned and let's walk together through this and see what we have today. Pay attention carefully, listen carefully. If you know there are distractions around you, change an environment. I've already explained this, that for learning to be effective, you have to understand your body, you have to understand your environment. If you are a type that can study in a noisy environment, no problem. But if not, wisdom requires that you go to the right environment that is good for you so that you get the best. Thank you. Let's go right into it. All right, so we have chemistry past questions today. So, so. Our first question here says the droplets of water observed around a bottle of milk taken out of a refrigerator are due to the fact that, all right, sometimes if you take out a bottle from a refrigerator, a cool bottle from a refrigerator, and keep it outside, after a little time, you observe water droplets around it. So, what's the cause of that? Have you ever asked yourself that kind of question? Science is interesting. I ask myself questions about many things, and it's interesting when you begin to discover how it actually works. That's what makes you different from somebody who did not go to school. You know why. You know the why behind things. Yes, you know the why behind things. So thank you very much. So let's quickly run through the options and see which one is good for us here. The first option says water vapor in the air around the bottle gains some energy from the bottle. This is not correct. Why? Because if water vapor gains energy, what happens? It moves away. It can never settle as droplets on top of the bottle. It is not the correct answer. It is not the correct answer. You and I knows that anytime molecules gain energy, anytime molecules gain energy, what happens? They get more kinetic energy to move randomly. They move more randomly. So if water molecules gain some energy from the bottle, how can they even gain some energy when the bottle itself is cool? So the energy we expect the water molecules to gain, it should be in form of heat. But the bottle is cool. So you see, sometimes if you use your brain alone, you'll be able to screen some questions that are not correct. All right, so let's go to the next option. The next option says, that's B, the temperature of the milk drops as it loses heat into the surrounding. Yes, this is true. If the bottle is in the fridge, the temperature of the milk drops. But does that affect the water, the vapor? Does that affect the droplets that we are talking about? Remember, we're talking about the droplets that fall on top around the bottle. So this is not the correct answer. Whereas the temperature of the milk drops while in the fridge, it will not make the water, that's not the reason why the water droplet settles alone. That alone is not the reason. Alright, so let's go to the next option, C. C says the saturated vapor pressure of the milk is equal to the atmospheric pressure. No. Now remember, the bottle of milk is closed, so the environment within the bottle is separated from the environment outside the bottle. So it's not necessary that their vapor pressure are equal. Even if they are equal, that will not cause the water droplets to settle on the bottle. What's the correct answer? See, you are already seeing it highlighted. So okay, don't worry, next time maybe I will not highlight correct answers. All right, so the correct answer is actually D, which says the water vapor in the air around the bottle loses some energy, loses some of its energy to the bottle. Do you remember thermodynamics? Yes. So energy always flows in the direction where it is low, from the higher the direction where it is high to the lowest direction. Something similar to osmosis, from the region of lower concentration to the region of higher concentration. Though osmosis has to do with semi-permeable membrane. Don't forget that. Oh, see, I'm already answering some questions in biology for you, using it to explain chemistry. This is why my class is unique. I will never answer questions in chem. In fact, if I answer one question in chemistry, it's equivalent to 3 or 4 questions that I'm answering, because the explanation I'm giving is always answering another question. That's why you need to watch this and listen carefully till the end. Don't just get the correct answer. No, listen to my explanations too. This is why my class is unique. I'm not after rush, or just say, question 1 answer is A, question 2 answer. No, I want you to know it. Appreciate the beauty in learning. Do you get what I'm trying to say? Let me give you an example now. If you put an iron rod in fire, what happens? The heat will begin to flow from where the fire is burning down to outside where the fire is not burning. Am I right? So do you see that there is a flow of heat? So the same thing. Since the environment inside the bottle of milk is cooler, are you getting me? So, and the outer is warmer, so the heat will flow from outside inside. Heat is a form of energy, right? Yes, heat is a form of energy. So the heat will flow inside. So as the heat is flowing, all the water molecules around begin to lose their temperature. They lose energy, therefore they settle down. Now, I have explained this in one of the physics class I have taken. The video is still on this channel. If you remember carefully, when we were talking about dew in physics, I explained that air has water in it. This is true. This air that is blowing, it has water. Oh, I hope you know that. That's why if you dry clothes, all of a sudden, the clothes are dry. Have you ever asked yourself where that water goes to? It enters into air, of course. We know that a little part of it falls to the ground, but then the rest goes into air. The rest goes into air. So I explained that air has water. Sometimes the level may be low and the level may be high. During the wet season, for example, the levels are usually high. That's why we experience dew. And we call it humidity, the amount of air, the amount of water in air. So if air is saturated with water, sometimes even in your skin, you'll be feeling it during the dry season. And there will be likelihood that water, if the temperature drops, it will condense and come back to its liquid form. Do you remember states of matter? Do you see where we are coming? So I just want to explain everything so that you get. So from liquid to solid, solid to gas, those are the three states of matter. So this time around, water in form of vapor in air condenses to liquid. That's gas to liquid. Do you get that? We call the process condensation. So the correct answer is D. Water vapor in the air around the bottle loses some of its energy to the bottle because the bottle is cooler. So the energy flows from the warmer direction into the cooler direction and causes the water droplets to form on top of the bottle. Thank you very much. I hope you get this question very well. If you don't get, the chat box is there for you. Ask your question. I will come up and respond to it. Let's go to question 2. Okay, part of question 2 is already here. All right, part of it says the volume of a given gas is V at P millimeter mercury. Hg means mercury. I hope you know that's the symbol for mercury from our elements. Yes. All right. So, and that's the unit. Millimeter mercury is the unit for measuring pressure. Okay, let me say that's one of the units because we have other units too. So now the question says the volume of a given mass of gas at a particular pressure. What is the new volume of the gas if the pressure is reduced to half at constant temperature? Make meaning out of this question now. Make meaning out of it. What it is saying is this. You have a gas at a particular pressure and temperature. Now, you now reduce the pressure. What do you think will happen to the gas? Yes. All right, this is what will happen. Pressure is more like force that is exerted on something. Let's say you have a flour, maize flour, rice flour, whichever flour you are familiar with. if you put it inside a cup, and let's say the cup is full, what happens if you apply pressure? You press it down. What happens? It reduces. So the volume reduces. Do you get that? That's the idea behind this. Do you understand? So that's how air behaves, or gas. Generally, if you apply pressure on gas, the volume reduces. You are applying pressure, you are exerting force on the gas molecules. So they tend to compact together, come closer together. Do you get it? Chemistry is interesting. Oh. Alright, let me tell you something. Do you know that you can fetch atmospheric air and toss it into liquid? Hey, it's interesting. Oh. It's interesting. Now, there is a process that is called fractional distillation of liquid air. This air is made up of nitrogen, oxygen, carbon dioxide, argon, and others. So, there are specific equipment that can be used to fetch air from the environment. Then, high pressure will be put on the air, and the temperature will be dropped. So if you drop the temperature and you continue increasing pressure, a time will come that it will become liquid. Are you getting it? Do you get me now? Alright, so that's it. So now in this case, now we have a temperature. We have a gas at a particular volume of gas at a particular pressure. Now the pressure has been reduced to half. What do you think will happen? The volume will increase. The pressure decreases. The pressure was like this. Now the pressure has been reduced, so the volume also will increase. If the pressure is reduced by half, which means the volume of the gas will be double. So the correct answer is 2V, which is B, which means the volume will be double the volume, because the pressure has been reduced by half. I hope you get this explanation. Please ask questions. Always ready to answer your questions. I don't want you to spend your time watching this you didn't understand and just go like that. Alright, so I have a little explanation there. My formula has scattered. Okay, maybe I will share it on WhatsApp group very well so that you will see it. But the explanation is based on Boyle's law, that says at a particular pressure, if you have constant temperature, at constant temperature, the pressure and volume are equal. So the pressure is proportional to volume. I hope this is well taken. Alright, so let's go to question 3. Question 3 says an increase in the pressure exerted on a gas at constant temperature results in, can you now see this? Similar question. Now I decided to bring these questions together because they are under gas law something, and these questions are not the same year. So do you now see how they ask questions? This one is similar to the above question, though not the same thing. So listen carefully again. An increase in the pressure exerted on gas at constant temperature results in. Now remember earlier we say it has been reduced to half, so volume increases. Now this time around it has been decreased. What do you expect will happen to the volume? You are seeing the answer boldly there already. The answer is there will be a decrease in the volume. Decrease in the number of effective collision. A is not correct. An increase in the average intermolecular difference distance. No, it's not correct. So this is still based on the Boyle's law, which says at constant temperature, increasing pressure reduces volume. That's inverse proportion. The volume of a given mass of gas is inversely proportional to. Inverse means as one increases, the other decreases. So as pressure increases, volume. As pressure sorry, let me take that again. It says if the temperature is constant, if pressure increases, volume reduces. If you increase pressure, volume becomes smaller. If you reduce pressure, volume increases. So that's how they work, the two work. It's inverse, not direct. Inverse proportion. As one increases, the other reduces. If volume increases, then definitely pressure will reduce. If pressure increases, definitely volume will increase. Thank you. So let's go to the next one. Alright, I will send this material also in the group. Please remind me. I will send it with the explanatory note, but that will be after you submit your assignment. So just remind me, I will drop it there. Alright, question 4 says the color of methyl orange in an alkaline medium is dash. The color of methyl orange in an alkaline medium is dash. Methyl orange is a pH indicator. If you put it in acid, it will be red. If you put it in neutral solution, it will be orange. If you put it in alkaline solution, it will be yellow. Don't forget this. Methyl orange. Red in acid. Acid is dangerous, right? Red in acid. Orange in a neutral solution, and yellow in basic solution. So take note of that. Let's quickly run to the next question. So the correct answer is yellow because they are saying in alkaline. Alkaline means basic. Yes, I believe you know that. Alright, so let's talk about question 5. Two hydrocarbons X and Y were treated with bromine water. X decolorizes the solution while Y did not. Which class of compounds does Y belong? This is organic chemistry. Now, bromine water is used to test for saturated and unsaturated hydrocarbons. Get this very well. It's a test for saturation to find out if a hydrocarbon is saturated or it's not saturated. What is saturation? Saturation has to tell us that there is no double bond between carbon to carbon in the compound. For example, alkanes with ANES, they are saturated, they don't have double bonds. They have single bonds all through, so they are saturated. Unsaturated like alkene. Alkene has double bonds somewhere in the chain or in the compound. So if you want to test for this, if you want to test for alkanes, you use bromine water. So that's the test for alkanes. I'm sorry, the answer here is not benzene. The answer is alkanes. Benzene has double bond. So in the presence of a catalyst, alkene also react. Benzene also reacts, so that the double bonds break. That's addition reaction. Sorry, the answer is D, alkanes. Thank you. We need to run. So the explanatory note is here. Alright, question 6 says elements in the same period in the periodic table have the same Alright, some people know this question already. They know, but some they don't know. I will not tell you. Alright, those that don't know, this is a bonus for you. So elements in the same period have the same number of shells. Please. Elements in the same group have the same number of valency. They have the same number of valence electrons in the outermost shell. Don't worry, one of these days I will get a board to explain some of these things so that I will write them and you see them clearly. Alright, so the correct answer is not atomic number, it's not chemical properties, it's not physical properties, but number of shells. The explanatory note is there. By the time I send it, you'll get it more. I don't want this video to be long. Let's look at the last question. The last question says the final product of the reaction between methane and chlorine in the presence of UV light, that's ultraviolet light, is trichloromethane, dichloromethane, tetrachloromethane, chloromethane. So the correct answer there, as you can see, is tetra. Tetra means 4. Remember, carbon can bond with 4 different groups or elements. So, in the presence of UV light, methane can react with chlorine to give tetrachloromethane. I hope this is very clear. So the is a radical substitution, free radical substitution. I don't want to take you into deep into free radicals. That's a very big topic. But let me quickly talk about trichloromethane. That A you see there. I saw one question one of the years in JAMB that they asked. The question was, which of the following is used as an anesthetic agent? Now, what are anesthetics? Before they carry surgery, the doctors make the patient to sleep. You know that kind of sleep. They will go unconscious. So one of these is used. They are injected with one of these, and that is trichloromethane. It is also called chloroform, and there is what they used to call soak and dye, something like that. There is one chemical that some people that used to drink hard drugs used to take. Yes, they will buy it, put in water, and so it's the same chemical, chloroform. So that's trichloromethane. In case you see it and they say anesthetic, the substance that they inject patients to make them die half or sleep or go into this deep sleep for them to carry out surgery, that is trichloromethane. Do you observe that I've answered another question now? Alright, now we end this class here. See you in our next class. Thank you so much. Subscribe now before you go. Subscribe so that you won't forget. I'm reminding you for the last time. Subscribe before you go. Like, invite others too that you know are preparing for these exams. If your friend succeeds, it should be a thing of joy. I'm out here making my own sacrifice and my own contribution to ensure that you get something tangible in this year's JAMB. You don't need to take JAMB again, and if you are passing it, you don't need 180. For God's sake, you should get a reasonable mark. If you are thinking the way me I'm thinking, I believe in excellence. I don't just want to pass, I want to pass well. If you are like that, keep following. Subscribe, like, and share with others, and keep following for other videos. Thank you. Have a good